9-8, sine, cosine, and tangent ratios. Sine, cosine, and tangent ratios are ratios that are going to relate the lengths of the sides of a right triangle to the angles within the right triangle, the non-right angles in a right triangle. We have sine, which is S-I-N-E. We will shorten it to 3 letters, which will be S-I-N, will still be sine. And the sine is the opposite over the hypotenuse. If we're looking at angle A, if we want to find the sine of angle A, we want the leg opposite angle A, which would be this side, and it's going to be the ratio of that distance over the hypotenuse. On this board, we're going to look at cosine, and the word is spelled cosine, C-O-S-I-N-E. And to shorten it, we'll just use COS, which is still going to be cosine. And the cosine is a ratio, and it's going to be the side adjacent to the angle you're looking at divided by the hypotenuse. So if we're looking at the cosine of angle A, the same angle we looked at before, this time we're looking at this distance, the leg adjacent to A, divided by the hypotenuse. And finally, we're going to look at something called the tangent, spelled out long. It's T-A-N-G-E-N-T. And to shorten it up, using 3 letters, it'll just be T-A-N. And the tangent is a ratio of the opposite side divided by the adjacent side. So if we're looking at angle A, it's going to be the leg opposite angle A divided by the leg adjacent to angle A. On this board, we're going to use the triangle PQR. It is a right triangle, and the right angle is at angle R. And you'll notice the capital letters, P, Q, and R, are the angle letters. And then there are also small p's, q's, and r's, and those are the lengths of the sides. I do want you to notice, and it is a standard thing, if we have angle P, side P, the length, is the side opposite to that angle. It's the side that does not touch that angle. That's a convention used when labeling triangles throughout math. We are told off to the side that side P is 12 units, side Q is 35 units, and side R is 37 units. And we need to find the sine, the cosine, and the tangent of angle P, and then we're going to find the sine, the cosine, and the tangent of angle Q. Instead of going back to each board every time to find the information we need, we're going to come up with something shorter. Something called SOHCAHTOA. This is going to be a lifesaver. It's going to make your life easy when trying to find sines, cosines, and tangents. On the first board, when we looked at sine, we knew that sine was opposite over hypotenuse. And then on the second board, when we did cosine, we knew cosine was adjacent over hypotenuse. And finally, when we looked at tangent on the third board, tangent is opposite over adjacent. So we have a SOHCAHTOA, which is a short form of telling us how to set up each ratio for the ones you need. So we'll jump right to it. We're going to find the sine of angle P. Angle P right here, and the sine is going to be opposite over hypotenuse. So the opposite is going to be little p, which is going to be 12, and the hypotenuse, which is r, is going to be 37. So the sine of p is 12 over 37. You're going to use a calculator at this point, and you're going to divide. And you get a bunch of decimal places, but it's very important that you keep 4 decimal places when you do these problems. So the sine of p, which is 12 over 37, is 0.3243. Now we're going to look at the cosine. The cosine of angle P is the adjacent over the hypotenuse. And so we know that side Q is adjacent to angle P, so that's going to be our numerator. and the hypotenuse is still r, little r, which is 37. So the cosine of angle P is given by the ratio 35 over 37. And when we divide that out, 0.9459. Our last example is going to be the tangent of angle P. And up on top where we have SOHCAHTOA, we're going to use the TOA, and we know that the tangent is opposite over adjacent. So we're going to end up with little p divided by little q. And the side opposite angle P is a 12, and the side adjacent to angle P, length Q, is 35. When we divide those out, we get 0.3429. So you've just found the sine, the cosine, and the tangent of each of these angles. Again, the sine, cosine, and tangent are simply going to be ways of relating the lengths of the sides to the angle measures inside the angles. Now we're going to look at angle Q, a different angle, this angle up here, because we have two angles that are not right angles in this triangle, so we can find the sine, cosine, and tangent of both of them. So now we'll find the sine of angle Q, the angle in the upper right-hand corner. So sine is always given by opposite over hypotenuse, and so the opposite is going to be side Q, and the hypotenuse is going to be side R. So the sine of Q is 35 over 37. And when we type that into a calculator, I get 0.9459. Now we want to find the cosine of angle Q. And we know that the cosine is the adjacent over the hypotenuse. And the side adjacent to Q is little p, and the hypotenuse is r. So our ratio is going to be 12 over 37. The side adjacent is 12 units, and the hypotenuse is 37 units. And when we do the division out, we get 0.3243. Finally, we're going to find the tangent of angle Q, which is going to be the opposite side over the hypotenuse, the opposite side over the adjacent side. So for angle Q, the opposite side is little q, which is 35, and the adjacent side is little p, which is 12. And 35 divided by 12 leaves us with 2.9167. If you take a moment and actually look at the sine of P, the cosine of P, the sine of Q, and the cosine of Q, you might notice something. They're related. The cosine of angle P is the same as the sine of angle Q, and the sine of angle P is the same as the cosine of angle Q. It works out that way because of the way the ratios and the way the sides are set up. So this is a portion of what you're going to need to do today. It is very, very important that you write SOHCAHTOA on your paper and commit it to memory as soon as possible, because this will show you exactly how to set up each of the ratios that you need to do. And this is what your work needs to look like tonight for your work. Finally, we're going to be presented with sine of 6 degrees and tangent of 42.4 degrees. And this is simply an exercise using a calculator. So you're going to need a scientific calculator, and you will type into the calculator the sine button and then the 6 and then hit enter, and it will give you the ratio of the opposite over the hypotenuse. And so the sine of angle 6 is 0.1045. And then we type into a calculator tangent of 42.4. You'll either type in the 42.4 and then hit the tangent button, or type the tangent button and then type in 42.4. It depends on the calculator you're using. You have to make sure you know. And we find that the tangent of 42.4 degrees is 0.9131. And you'll have a couple of problems where all you have to do is type them into a calculator. Your homework is on page 480 and 481, problems 13 through 26, all of them.